Hello everyone, we are the Group 3 from BSED Science 3A and the group members are the following. Shidel Lucing from BSED Science 3A, Kimberly Orbeta from BSED Science 3A, Santa Manicani from BSED Science 3A, Rose and Joy Pinili from BSED Science 3A, and Mark Lewis Ron from BSED Science 3A. And in this video, we are going to present our two critic paper about the two research article that we have chosen. And this was submitted to Miss Rose and May Ramos. So our first critic paper is about the research article entitled Understanding the Nature of Science and Scientific Progress, a Theory Building Approach. So this critic paper is made from the published research article entitled Understanding the Nature of Science and Scientific Progress, a Theory Building Approach, and authored by the following: Maria Choi, Marlene Escardamalia, Carl Beritzer, Flor Prinsen, Monica Rosendes, Richard Messina, Winifred Hansberger, Chris Teploves, and Angela Chow. This article was published on November 2010 at Canadian Journal of Learning and Technology. So the purpose of this article was achieved, which is to inform that the theory building approach is a good way to increase students' understanding of nature of science through conducting a natural experiment. For evidence bearing on the effects of educational approach, they turn to comparison of the experimental and the comparison groups who were similar in demographic characteristics. Briefly, the experimental group taking a theory-building approach scored significantly higher than the comparison group on overall scientific literacy and on 3 of the 4 separately scored traits. The exception was invention, which was not a focus of inquiry in either group and which did not show either a significant group difference or significant change from pre to post test. So in this article, the authors were able to state the 3 levels of understanding that is related to the understanding the nature of science. In the first level of understanding, the scientific knowledge consists of a simple collection of facts such as how to do something correctly or describing what happens. In this level, there is no clear differentiation between theories, hypotheses, or experimental results, nor recognition of the role of ideas in scientific inquiry. In the second level, the scientific knowledge is no longer considered a collection of facts, but of tested ideas. So scientists do experiments to see if their idea is correct and revise this idea if it is proven wrong. The two important notions that appear in this level are explanation and hypothesis testing. And the two main questions of preoccupation are how things work and why things happen. Lastly, in the third level, scientific knowledge is represented in theories about the world, theories that should not only explain phenomena but also predict them. According to Smith et al. Of 2000, a theory is understood as a coherent explanatory framework that consists of a network of hypothetical theoretical entities that are used to explain patterns of data. So at this level, individuals understand that theory guides various phases of scientific inquiry from the formulation of hypotheses and to the interpretation of the results. On the other hand, the authors also identified the 3 problems of understanding the nature of science. The first problem is related to the differentiation between theories and facts. Kenneth Miller pointed out the pervasive confusion about the meaning of the terms theory and fact. He explained that theories are not speculative hunches that may someday become facts when scientists gather enough evidence for them. Theories don't become facts. Theories explains facts. This means that in scientific terms, theories actually present a higher level of understanding than facts. The second problem concerns the nature of theoretical progress, notably, how are scientific theories improved? On one hand, theories are judged stronger if they explain more facts. The final problem of understanding refers to the discovery process. Where do theories come from? How do people invent things? What happens when scientists get stuck? The answers to these questions are closely connected to understanding the role of ideas in scientific inquiry. The authors had also clearly stated their hypothesis about the study, which is they expected that students pursuing a theory-building approach would demonstrate higher scientific literacy levels than those of the comparison class. In the methodology part, they have stated their participants for the study, which were 9 and 10-year-old students from 2 grade 4 classes in Canada, as well as the procedure in conducting their study, which is to individually interview the students outside of the classroom by a researcher for about 40 minutes. In the presentation of the results and discussion, they provided a table about the results of the experiments in the experimental class and comparison class. It is clearly seen that they used statistics, for they used the mean scores and the standard deviations in interpreting the data. The table made it easier for the reader to interpret and understand the results for the general scientific literacy level, the nature of theoretical progress, the theory of fact understanding, the rules of ideas in scientific inquiry and invention, though there are explanations following below this table. After reading the whole article, we realized that the intended audience for this article are the teachers and students. The terminologies that was used are easy to comprehend, and everyone who will try to read will be able to understand this article. If I were to rate this research article, I would rate it 10 because the construction is very detailed and they were able to discuss and interpret the results of their studies. They also give the general discussion or somewhat the whole summary of their research in the last part so that it will be easier to understand. The researchers also provided sufficient references following an APA format for this research article. Lastly, this article is a great help for every one of us, most importantly to teachers and students. As stated in the introduction of this article, science creates knowledge and so its importance continues to rise. That is why scientific literacy is no longer considered an attribute to privileged class but a societal necessity. The most desirable goal of most of the educational systems is to create scientifically literate citizens who will be able to understand the scientific enterprise and can participate intelligently in political decisions relating to science.
Good day, ma'am. We are the BSED Science 3A students, Group 3, to present our critic paper and our chosen second article entitled The Nature of Science and Scientific Knowledge, Implications for Designing a Pre-Service Elementary Methods course. I am Shidel to present the introduction of our critic paper. So, in her article entitled The Nature of Science and Scientific Knowledge, Implications for Designing a Pre-Service Elementary Methods course, Yvonne J. Mitchtree presented a discussion on the implications of teaching the nature of science and scientific knowledge in a pre-service elementary methods course setting to the students. It is also discussed in the article the challenges and the decisions in the reformation of science education and various definitions of the dimensions of scientific literacy from different authors together with their distinctions were presented. What aspects need to be included to fully represent the multifaceted nature of science? What are the most effective ways of developing these understandings, and what is a realistic expectation in the context of this course in regard to developing these understandings? These were the three questions raised about the said topic, which are the elements that this paper is planning to examine. Upon reading the article, you will discover that the purpose of designing a pre-service elementary methods course is to develop the scientific literacy of the learners. It aims for the students to have a clear understanding of and possess accurate views about the nature of science and scientific knowledge. In this article, the teaching considerations which are related to the nature of science and scientific knowledge in elementary science teaching and the educational approach used during the program of study to develop understanding of the nature of science and scientific knowledge in pre-service teachers are described. The decisions made together with its rational foundation and challenges evident, the results of practicing the instructional strategies based on the views on teaching, the nature of science and scientific knowledge and considering its impacts to the students' learning are presented and discussed. At the end of the article, a conclusion was made discussing the implications of teaching a pre-service elementary education science methods course to the learners.
The curricular materials and classroom observation and interview data used to explain the result of MECTRE's study provided evidence that the nature of scientific knowledge was not always being directly conveyed to students through either the written curriculum of BSES or by the teachers. For example, even though students designed several experiments that required them to use creativity, neither the written text or teacher would directly inform students that this was a process used by scientists to generate scientific knowledge. MECTRI concluded that when the curriculum or teacher did not directly relate the content students were learning or processes they were using to the separate dimensions of the nature of science defined in this study, it is reasonable to expect that the students did not make this connection themselves. One implication made evident by the result of MECTRE's study is that the mere use of a program designed to develop student understanding of the nature of science is no guarantee that such understanding will develop. Another essential part of the examination is the aspects presented regarding the nature of science are partly conducive into studying and understanding the nature of science and the scientific knowledge. Just that the ways described of developing the scientific literacy of the learners do not fully meet the demands of the needed inquiry.
Throughout the context described, discussed, and presented, the goals of designing a pre-service elementary method course will be accomplished through an effective teaching performance of all the science educators, may it be in primary and secondary schools and the universities. The inquiry process will be seen or achieved by providing the students an adequate representations of all the nature of science and scientific knowledge.